Welcome to this lesson on the science of the Inventor Identity Loop. Today we're going to explore how curiosity drives a powerful cycle of learning that creates neuroplastic mastery. The Inventor Identity Loop is a self-reinforcing cycle that transforms how your brain learns and creates. It consists of 5 key stages that feed into each other. Here's the complete cycle. It starts with curiosity at the top, moves to micro-study, then micro-experiment, followed by reflection, then next hypothesis, and cycles back to renewed curiosity. Let's dive deep into the first stage, curiosity. Curiosity is the initial spark that ignites the entire learning process. When you experience curiosity, your brain's reward system activates. Specifically, the ventral tegmental area releases dopamine, which heightens attention and memory formation. Why does curiosity actually improve learning? The answer lies in neuroscience. When dopamine floods the hippocampus during curiosity, it creates what scientists call a primed learning state. Your brain becomes like a sponge, ready to absorb information. We can express this relationship mathematically. Learning rate is proportional to dopamine level. When dopamine increases, your ability to encode memories increases. The second stage is micro-study. This is not about reading textbooks for hours. It's about focused, deliberate learning in short bursts. Micro-study typically means 15 to 30-minute sessions of highly focused learning. This duration is optimal for maintaining peak attention. Research shows the brain can sustain peak focus for approximately 25 minutes before attention starts to wane. This is why the Pomodoro technique works so well. Here's the micro-study cycle visualized. 25 minutes of intense focus, followed by a 5-minute break. Then repeat. This pattern maximizes neuroplasticity. During these focused sessions, synaptic connections between neurons physically strengthen. This is the basis of neuroplasticity. We can model synaptic strengthening with this equation. Delta W represents the change in synaptic weight. Eta is the learning rate, multiplied by neural activity and error signal. Stage 3 is micro-experiment. This is where learning becomes active and embodied. You don't just consume information, you test it. A micro-experiment could be as simple as explaining a concept out loud, building a quick prototype, or solving a practice problem. The key is active engagement. Here's an important question. Why is active testing so much more effective than passive review? The answer is retrieval practice. When you actively recall information, you strengthen the neural pathways much more than simply rereading. This is called the testing effect. Studies show passive review leads to only 20% long-term retention, but active testing boosts retention to 70% or higher. Memory retention follows an exponential decay. R0 is initial retention, T is time, and tau is the decay time constant. Active testing increases tau significantly. When you run a micro-experiment, you're creating what neuroscientists call prediction errors. Your brain predicts an outcome, then compares it to reality. These prediction errors are the fundamental driver of learning. When your prediction is wrong, your brain updates its internal model. This is how you actually learn. Stage 4 is reflection. This is the most underrated part of the cycle, yet it's absolutely critical for deep learning. During reflection, you step back and analyze what worked and what didn't. You're not just learning content, you're learning how to learn. Brain imaging studies show that the prefrontal cortex becomes highly active during reflection. This is the part of your brain responsible for executive function and metacognition. Good reflection asks 3 key questions. What did I learn? What surprised me? And what would I do differently next time? These questions activate deep processing. Interestingly, the reflection process continues even after you stop consciously thinking about it. During slow-wave sleep, your brain replays and consolidates what you learned. Memory consolidation is proportional to sleep quality. Studies show that people who get adequate sleep after learning retain up to 40% more information. The 5th stage is forming your next hypothesis. This is where the loop closes and reopens simultaneously. When you reflect deeply, you naturally generate new questions. These questions spark renewed curiosity, which drives you back to stage 1. Here's the beautiful part. Each cycle through the loop builds upon the previous cycle. Your questions become more sophisticated, your experiments more insightful. Visualize it like this. Each cycle is a growing spiral. You're not just repeating, you're ascending to higher levels of understanding with each iteration. Now let's talk about the neuroscience behind why this loop creates self-reinforcing mastery. Neuroplasticity is your brain's ability to rewire itself based on experience. Every time you complete this cycle, you're physically changing your brain's structure. We can model skill acquisition as an integral. Your skill level is the integral over time of practice quality. The Inventor loop maximizes practice quality at every moment. With repeated practice through this loop, myelin sheaths grow around the neural pathways you use. Myelin is like insulation on a wire. It speeds up signal transmission. Signal velocity in neurons increases with myelination. The myelin factor can increase conduction speed by up to 100 times. This is why experts process information so much faster. Let me give you a powerful analogy. The Inventor Identity Loop works like compound interest in finance. Just as compound interest grows exponentially because you earn interest on your interest, this loop grows exponentially because each cycle not only adds knowledge, but also improves your ability to learn. We can model knowledge growth as K of t equals K0 times e to the RT, where K0 is initial knowledge, R is your learning rate, and T is time invested. But here's the key insight. The learning rate R itself increases with each cycle, so you're not growing linearly or even exponentially with fixed rate. You're super exponential. Here's what that looks like graphically. Early on progress seems slow, but as your learning rate increases, knowledge growth becomes explosive. Another powerful analogy is the flywheel effect from physics and business. A flywheel is a heavy wheel that's hard to get moving initially, but once it's spinning, it has so much momentum it becomes almost unstoppable. Each cycle through the Inventor Identity Loop is like one push on the flywheel. The first few pushes seem to do nothing, but with persistence, the wheel starts turning. The kinetic energy of a flywheel is 1/2 I omega squared, where I is moment of inertia and omega is angular velocity. Notice it's quadratic in velocity. This quadratic relationship means that later cycles through the loop become dramatically more productive than early cycles. Your learning compounds on its. Now let's discuss practical applications. How do you actually implement this loop in real life? Let's say you want to learn a new programming language, Curiosity stage. What can this language do that others can't? Micro-study. Read documentation for 25 minutes. Micro-experiment. Write a small program to test one specific concept you just learned. Don't try to build something big yet. Reflection. What worked smoothly? What error messages did you encounter? What did those errors teach you about how the language works? Next hypothesis. Based on those errors and insights, what's the next small thing you should experiment with? This generates renewed curiosity. Application 2 is scientific research. The Inventor loop is actually how real scientists work. Curiosity. A scientist observes a phenomenon that current theories don't fully explain. This sparks deep curiosity. Micro-study. They do a focused literature review, reading relevant papers for 30 minutes at a time, taking detailed notes. Micro-experiment. They design the smallest possible experiment that could provide insight. Maybe just one measurement or one trial. Reflection. They carefully analyze the results and compare them to their predictions. Where did reality differ from expectation? Next hypothesis. They refine their theoretical model based on the new data, generating a better hypothesis to test next time. Let me give you a numerical example to quantify how powerful this loop can be. Let's assume you complete one cycle of the Inventor loop per day, and each cycle improves your learning rate by 10%. Your learning rate after n cycles is R0 times 1.1 to the n, where R0 is your initial learning rate and n is the number of cycles. After 30 days, 1.1 to the 30th power is approximately 17.4. Your learning rate has increased more than 17-fold. After 100 days, 1.1 to the 100th power is about 13,781. Your learning rate has increased almost 14,000 times. Total knowledge accumulated is the sum from I equals 1 to n of R0 times 1.1 to the I. This is a geometric series that grows explosively. This mathematical model explains how experts in any field develop what seems like superhuman ability. It's not magic, it's the power of compounding learning. Now let's talk about the identity transformation aspect. Why is this called the Inventor Identity Loop? Your identity is fundamentally the story you tell yourself about who you are. When you repeat this loop consistently, your identity shifts. You shift from thinking, I am trying to learn something, to, I am an inventor. I am someone who naturally asks questions and experiments and discovers. Why does this identity shift matter so much for learning outcomes? Because when something becomes part of your identity, you do it automatically. You don't need willpower or motivation. It's just who you are. Here's the transformation visualized. You start with an identity of, I'm not good at this. After 100 cycles through the loop, your identity has shifted to, I am an inventor. Each successful cycle through the loop provides evidence to your brain that yes, you are capable of learning and creating. This reinforces the inventor identity. Dopamine plays a crucial role, not just in learning, but in identity formation. When you complete a cycle and experience the satisfaction of discovery, dopamine is released. This neurochemical marks the behavior as worth repeating. The probability of repeating a behavior follows a sigmoid function of the dopamine change delta D. As dopamine reward increases, probability of repetition approaches 1. Over time, the inventor loop itself becomes intrinsically rewarding. You don't do it for external validation. You do it because the process itself feels good. Let's discuss common obstacles people face when trying to implement this loop. Obstacle 1 is impatience. People want to see dramatic results immediately. But remember the flywheel analogy. Early cycles feel slow. The solution is to focus on the process, not the outcome. Your only goal is to complete one more cycle. Trust that results will compound over time. Obstacle 2 is perfectionism. People try to make their experiments too elaborate. They want to build the perfect project before testing anything. The solution is to make your micro-experiments ridiculously small. Can you test one tiny aspect in 5 minutes? That's the right size. Obstacle 3 is skipping reflection. People rush from experiment to experiment without pausing to extract insights. The solution is to journal for 5 minutes after each cycle. Write down what surprised you, what you learned, and what you want to try next. Here's an advanced strategy. You can apply the inventor loop to the inventor loop. This creates meta-cycles. Use curiosity to ask, how could I make my micro-studies more effective? Experiment with different study techniques. Reflect on which techniques worked best. You have your main loop where you're learning a subject. Then you have a meta loop where you're learning how to learn that subject more effectively. This creates recursive self-improvement. You're not just getting better at a subject. You're getting better at getting better. Let's connect the inventor loop to broader principles in learning science. The loop naturally incorporates spaced repetition. Each cycle revisits concepts, but with increasing sophistication. It uses interleaving because each hypothesis builds on previous understanding, connecting new knowledge to old knowledge. It employs elaboration through the reflection stage, where you explain concepts in your own words and make connections. It leverages the testing effect through micro-experiments, which are essentially retrieval practice in disguise. Effective learning is a function of spacing, interleaving, elaboration, and testing. The inventor loop elegantly integrates all 4 principles. What are the implications of this framework for education systems? Traditional education often breaks this natural cycle. Students study disconnected facts, rarely experiment, and reflection is limited to grades. A better approach would be designing curricula explicitly around these microcycles. Every lesson includes all 5 stages. Students should spend much more time actively experimenting and reflecting, and less time passively listening to lectures. The long-term vision is creating lifelong learners who never stop growing. Once you internalize the inventor identity, it transcends any single subject. You can apply this loop to learn anything. You become what Nassim Taleb calls anti-fragile. You don't just survive change, you thrive on it because you love learning. The inventor identity sits at the center, connecting to all subjects you learn. It's the universal skill that makes every other skill easier to acquire. Let me recap the 5 stages one final time to solidify your understanding. Stage 1, curiosity. Ask genuine questions that spark your interest. This activates your brain's reward system and primes you for learning. Stage 2. Micro-study. Study in focused 25-minute bursts. This maintains peak attention and maximizes information encoding. Stage 3. Micro-experiment. Actively test your understanding through small experiments. This creates the prediction errors that drive deep learning. Stage 4. Reflection. Step back and analyze what happened. Extract insights not just about the content, but about your learning process. Stage 5. Next hypothesis. Formulate new questions based on your reflection. This regenerates curiosity and closes the loop. The cycle repeats endlessly, but each iteration operates at a higher level of sophistication than the last. As we conclude, think about your own learning journey. You have the power to physically rewire your brain through this process. Neuroplasticity means you are not stuck with the brain you have now. Every expert you admire started as a complete beginner. The only difference is they consistently ran through this cycle thousands of times. You can start today with just one microcycle. Pick something you're curious about. Study it for 25 minutes. Run a tiny experiment. Reflect for 5 minutes. Form your next question. Mastery is the limit as n approaches infinity of the sum of all your cycles. There is no shortcut. But with this framework, the journey itself becomes joyful.